Hi everyone. I hope each one of you is doing good. So we have started the journey with the reading comprehension tests. Okay. So reading comprehension. In reading comprehension, you have to open yourself to different type of passages, and this passages is mathematically oriented. Most of the passages of the CAT background do not come from this specific genre, but you have to link through, right, everything that you can come across. So let us start with this RC. A tendency to drastically underestimate the frequency of coincidence is a prime characteristic of innumerate people who generally accord great significance to correspondence of all sorts while attributing too little significance to quite conclusive but less flashy statistical evidence. So this is the general statement that we would follow. Okay, we would keep on finding other general statements also. If they anticipate someone else's thought and have a dream that seems to come true, or read that, say, President Kennedy's secretary's name, Lincoln. Okay, well, this is an example. I won't read it. You can read it after taking some time. Okay. The surprising likelihood of coincidence. So what is this? Let us summarize this. Okay, I'm summarizing this as one. Okay, paragraph 1 says that, just a minute, I won't have space afterwards, so that I would summarize it here. Okay, so the paragraph 1 says that, let's summarize it in red. The tendency to drastically underestimate the frequency of coincidences is prime characteristic of innumerate people, okay, who generally accord great significance to correspondence of all sorts while attributing too little significance to conclusive but less flashy statistical evidence. Okay, so statistical evidence right, is given less importance by people. That is all. That is all we need to have in mind for now from the first paragraph. Now, the surprising likelihood of coincidence is illustrated. Now, illustrated depicts an example. Right, illustrated depicts an example by the following well-known resultant probability. Since a year has 366 days, okay, there would have to be 367 people gathered together in order for us to be absolutely certain that at least, so this is a statistical analysis, right? Though it might be wrong, right? But there would have to be, gives us a specific area of disagreement. Okay, disagreement or generalization, I would say. Okay, it may have exceptions. Okay, so 367 people together in order to, there are 366, this is saying that there are 366 days. So if we have 367 people, then we would have one person, at least one person extra. Okay, at least one person extra. So two people would have, there would be a likelihood. Okay, remember the word likelihood. Okay, inference questions might come from this type of passages. So likelihood, there is a likelihood that 367 people gathered together in order for us to absolutely certain that at least two people in the group have the same birthday, right? I have given you the explanation of the last few sentences. Okay, now let us move to the next part. Okay, so I would write down the second one. Okay, analysis of the second one. So okay, 367 people, in 367 people, two people, at least two people. Okay, I'm adding some modifiers step by step. At least two people might have same birthday. Okay, so this is quite significant. Okay, now third one. Okay, third one. Now third one, how would we do the third one? Okay, the third one, let me see how I can scroll it down. Okay, so we are Now, what if we are content to be just 50% certain of this? That is, how many people would there have to be in a group in order for the probability to be half that of at least two people in it have the same burden. So probability, this is the number of probability, not try to think it in terms of the real life example. So we are having half the probability, right? 50% certain of this, right? That we might say that there is a 50% chance that, okay, there are half of the chance if we are taking certain group, right? This is a real life example. Let us see. If we are taking 367 people, right? We took two group A and a group B, right? Okay. So in group A and group B, there would be two people and two people, right? In most of the cases, in 99% of the cases, statistically, there would be two people and two people, at least two people who would have the same birthday. But how many people do we need in this group so that we can say that one of these groups might have some people, at least two people, right? One of these groups might have at least two people. So the author is giving us an answer, right? An initial guess might be 183. Okay, 183. Okay, about half of 365. Okay, that seems to be good. The surprising answer, he has used surprising. Notice this here, right? He has used surprising. Surprising answer is that there need be only 23. Right? Surprising answer is that there need to be only 23. So if we place 23 in this and we place 23 in this, one of these groups would have a person two people who have same birthdays, right? I'm talking in the group, either in group B, either in group B, right? Okay. So this, okay, startles us. Stated differently, half of the time, the 23 randomly selected people are gathered together, two or more of them will share a birthday, right? Half of the time, I have taken half of the time, right? Half of the time that in group A or B, there might be people in which two or more people would have the same birthday. Okay, he is quite sure about that. I do not know whether I would be sure about that or not. I would have to check the statistical evidence. Okay, let us move to the next paragraph. Okay, third one has given us, okay, only 23 people needed for half probability, surprising. Okay, I am writing the tone here. Okay, this is good to go with. For readers unwilling to accept this on faith, here is a brief derivation. By the multiplication principle, the number of ways. So what they are doing, they are choosing some of the birthdays, right? 365, 364, how they are choosing, I would explain it now. 1, 2, 3, 4, 5. So we have to choose a day, right, on which someone's birthday falls. So we have 365 days at the start of the month. So we have 365 days to choose. Now we have chosen one day, let's say we have chosen 26th of July. Okay, then we have only 364 days to choose from. Again 363 when we have filled this. Again 364 when we have filled this. Again 361 when we have filled this. So this is how many choices we have, right? So the number of choices we have to fill the places. Okay, now he has filled the places, okay, through here. It's such that no two dates are the same. Any of the 365 days may be chosen first, any of the remaining 364. So he has explained it properly. If you are not able to understand it, just have a look, just go through the sentences first and then, okay, then view the explanation. Thus, by dividing these two data product, okay, by 365, so 365 into 365 into 365 5 times would give us this total probabilities, total number of days that might come in that period. Okay, 3655. Okay, let us see. We get the probability. This was the total number of repetitions, allowed repetitions, right? This is in the denominator, this is in the numerator. Okay, this is the first one in the numerator, this is the second one, number in the denominator. Okay, so let us move ahead. Okay, thus by dividing this letter product, we get the probability of 5 people chosen at random will have no birthday in common. Okay, So, okay, these people would have no birthday in common. Now, if there is a 100% probability of anything happening, right? 100% probability of anything happening, or the probability in fraction remains 1. Okay, so we can subtract this number of having no birthdays in common, and if we subtract no birthdays in common in all the number of probabilities, what would we be left with? 2 or more people, okay, equal to 2 or more people, probability of 2 or more people, probability of 2 or more people having a common birthday, having a common birthday. Okay, so this is the one. Now, if we subtract this probability from 1, okay, that is what I have done. So they have given the result. Okay, 23 people would come. So this is the statistical calculative proof of what we have read, okay, in the last paragraph. So fourth one is giving me a statistical proof, right? Calculational proof. So fourth one is giving me a calculation based proof. Okay, now the fifth one. This is an example from a, okay, now this is an example from a television show. Okay, believe it, noted that there were about 120 people of studio audience, whatever, right? This you can read on yours, by yourself. Okay, by yourself, you can read it. So we would move to the questions. Okay, let us write what has been given in the fifth one first. Okay, TV show example of a mistake. Okay, I won't read, I won't write it about probability. We have the whole idea in our mind now. Okay, now let us move to the first question. What has been given here? Choose the best title for this passage. Okay, the first one is birthday coincidence. Now you should be clear with the main idea while doing this question. Okay, best title. It would be a main idea, just okay, just phrased to 2 or 3 words. Okay, we have been seeing there are 3-4 words or minimum 2 words. Birthday coincidences. No, what has been given in the first sentence was a general sentence. Statistical evidence is given less importance by people. Okay, I hope we are sure about this. Okay, I hope we are sure about this. So main idea is there, birthday coincidences, the probability of birthdays, probability and coincidence, the importance for this. Okay, was it the probability of birthdays? Okay, this would be a difficult one for those who do not write the main idea. Birthday coincidences is not going with the general sentence that statistical evidence is given less importance by people. This is a more general idea, right? Even he was giving a mistake, he was doing a mistake, right? So birthday coincidences would not be the go with the general sentence. Okay, general statement that was made in the first one, which gave the backdrop of the whole idea. The probability of birthdays. Moreover, many of you might have been confused. Okay, let me see. Let me see. Okay. The surprising likelihood of is illustrated. So this was an example. The word illustrated gives an example of this. Okay. Now let us move to the question. Okay. So the probability of birthdays. No, the probability of birthdays is again an example. Probability and coincidence. This is what has been given in the general sentences. So let us keep it that way. The importance of coincidences. Okay. Were we talking about the importance of coincidence or people not knowing the statistical evidence, the relation between statistical evidence and coincidences, right? The importance of coincidences, he said in the first statement itself, that you can check it right on your own, that it was not about the coincidence. He was saying that people do not check how often statistical evidences give away what are often perceived as coincidences. That is the whole idea of this, right? Now, third one. Okay, third one, we have done the third one. Now, fourth one would be wrong, obviously. Okay, so let's erase it all now. We would move to the next question. Let us see the next question. So this is a different type of question. Read the following statements. Statement one, probability that in large group, someone in the group has the same name as the group leader. Okay. Statement two, the probability that in a large group, two people in the group have the same name. These are really difficult probabilities, but we would have to derive an explanation. Okay. Now, when we go through the options, the probability in statement one is higher. Okay. Let us read the question first. What is the relationship between these two probabilities based solely on the information in the passage? I am not sure about the relation, which relationship he is asking about. Now, the probability in statement one is higher. Okay, higher or lower. Both statements are equal. Now, probability in a large group, someone in the group has the same name as the group leader. Okay, large group, in large group, it would be more. The probability in a large group, two people in the group have the same names. Okay. So same name as group leader. In the last paragraph, he was saying that we cannot talk about a specific probability, right? For example, if we take an example of 19th March as a birth date, and then we tend to find it with another person, that would not be the same if we are finding two people with the same birthday, whichever date it may be. So we have a freedom of choosing the dates here. Now, in this case, what are we choosing? Same names and a specific name. A specific name would be rather difficult to find and would be dependent on the name rather than finding the same names, right? So two probability, the probability of one would be lower than in the statement two. Okay, the questions are a bit, okay, half. Okay, statement two, then in statement two. Okay, now, okay. Now let us move to the third question. Which of the following is the least likely source of this paragraph? Okay, least likely needs to be kept in mind here. So we have seen an example given from an anecdote given from a TV show, right? Such anecdotes are not given in textbooks, right? TV show anecdotes are not given in the textbooks, right? They generally give those examples which are prevalent through the time. TV shows are not prevalent through the time. They generally wane away from our. So second one would be the right answer, right? Second one would be the right answer. I hope this is clear. If it is not clear, you can always connect with. Now, let us move to the fourth question. Okay, I have gone really down the south. Which of the following questions cannot be answered based on the mathematical information or methods given in this passage? Okay, so how to do these questions? If we notice these questions, right, cannot be answered based on the mathematical. So if we notice the patterns of some of the options would be same. How large does the group need to be probability to be half the birthday someone not killed? We have discussed this. How many people would there have to be in a group for there to be 90% probability? On the basis of that, whatever evidences has been given, 90% probability at least two people in it having the same birthday would have to be. I have given either. You have to take 10 groups in this, right? You would have to take the 10 groups in this. Okay, then calculate the probability of all those groups, right? Or you can calculate on the basis of whatever calculation method has been given for the 50%. Okay, the real life example would be on the basis of 10 groups. Okay, so this can also be done. How many people would there have to be in a group for there to be absolute certainty that at least two of them have a birthday in the same month? We have talked about this. But what is the chance that a person's birthday is in January 1? That was not at all relevant to whatever has been given in the passage. So this would be the example, right? Moreover, in the last paragraph, he was telling us not to take a specific value, which goes against the last paragraph. So this first option would be the right answer all through and through. So here I am signing off with the today's passage, like after discussing today's passage. Okay, if you have any queries on the basis of this video or this passage, you can always connect to me. Okay, for those who are watching this video and are not enrolled in the batch, the batch size is quite low. It remains around 40 to 50 students till now. We have a roof value of 60, right? Higher value of 60 students at most in the group. Okay, fees would be 4.5. Right. So, okay. So yeah, that is all for today. Bye.